Hello. Today we're going to talk about the application of ideal gas law. Okay, so just a quick review that ideal gas law says that P times V is equal to nRT. And that's also equal to nKT. Okay. And two things that's student often forgot is that P here, the pressure, it's in absolute pressure. So it's not a gauge pressure. And the other thing is that T is also in the absolute scale, right? So both are in absolute scale. So this is degree K. So these two things are very important. So that's the unit that we use in formulating this equation by the early physicists. All right, so now we're going to apply this equation here, and we're going to introduce, review this one again. This one is called universal gas constant. And that's equal to 8.31, and then joule and mole, and then degree K, okay? And we can also using the Boltzmann constant here too, right? So I'm going to give a question here, example. Say if I have a noon, okay, and it's sealed, right? So the V is equal to constant, okay? And let's say if I, make this noon hotter by putting some kind of heater on, right? So originally the T1 is equal to say 20 degree C, okay? And you put the heater on, and now it's at T1 equal to say 30 degrees C, right? Let's say you like it to be really hot, right? Well, it's pretty hot, 30 degrees C, right? In the winter time. And now you ask yourself, right? Let's say originally it was P0 equal to 1 atm, right? So then you ask yourself, after the temperature go from 20 to 30, what will be the P, right? The P, we call that, P0, so this is T2, okay? So we'll just call it, just for now, we're going to call that P1, okay? P1. I'm going to say, well, what is the P2 now? Once we change the temperature from 20 to 30, what is the atmospheric? So this is the atmospheric pressure, ATM pressure, right? At T2, okay? Right, so that's the question. So how are we going to solve this question by using our formula, right? So I'm going to change in color here, make it to, okay. All right, so we know P1, we're going to do it general, right? So you can apply it anywhere else. So N1, or N, right? N is not N1. So NR is fixed. So we're saying that the number of, so N is fixed. N is a constant because air is trapped here. Air is trapped. Okay? So N is constant and R is constant, but P1 could change. But V is constant, so we don't need to have V1 here. V is constant. This is the noon, right? The door is open, it's closed, right? The door is closed, right? The door is closed, closed door. And there's no window, it just is trapped, right? So the air is trapped. Air is trapped, right? So V is constant, but T can change. So T, right? So I'm going to say T1. And you also have P2, V equal to NR T2, right? Okay. And now you divide the left-hand side and divide the right-hand side. You see that P1, P2 is equal to, this cancel out, right? So you divide the top, right? So you have 1 and 2. So basically you take 1, you divide by 2, okay? And this side is the left-hand side, LHS. And this side is the right-hand side, RHS. So this NR cancel out. So you have T1 versus T2. So then you can use this one here now conveniently to solve this equation, this problem. All right, so I'm going to change in color here. Okay, so I'm going to use this little space here. I'm going to erase a little bit here. Eraser. I'm going to erase this. I don't need that. Okay. Okay. All right. Okay. All right. So that's probably enough. Drawing again. Okay. So now I'm looking for P2, right? So from there, right, from equation 3, I'm going to rewrite it here. So P2 is equal to P1 times T2, right? So P2, P1 times T2 divided by T1. Right? Okay? So this one says that if my temperature goes up, then my pressure would also goes up, right? So this one here says that in this condition, right, as temperature goes up, pressure goes up, right? So they are linearly proportional, right? So T are linearly proportional to P. So that's what this equation says. All right, so then you see T2 is larger than T1, so P2 will be larger than P1, okay? So now that's changing this to the Kelvin scale. This is Celsius, right? So from Celsius to Kelvin, right? It's just adding 273, right? Okay, so then you have T1 is equal to 293 degree K, and T2 is equal to 303 degree K. Right? So all you have to do is you put the P1 there. So P1 is 1 atm, right? So you can keep that as a 1 atm, right? If you don't mind, P2 will be listed as 1 atm, and then times 303 divided by 293, and then you can find out what's the P2 equal to. All right. So we're going to stop there for today's lecture. Yeah, thank you. We'll see you next time. And